I honestly didn't think it would be that easy. I almost didn't listen to you guys. Like, thank goodness I read my comments. So if anything, just let this video kind of be a reminder to you that you should properly evaluate certain things. Like, actually give it like some time before you decide that that's not an appropriate solution for you. All right, what's up guys? My name is the Cherno and I'm building a game engine. That's gonna be my intro probably from now on. So for those of you a little bit out of the loop, I have been setting up like some kind of automated testing situation for Hazel, the game engine that I'm building, because I want to reduce some of the pressures of testing from the team, and I'll have the previous video linked up there, so suggest you check it out because it explains a lot more about the context of what's going on. But the goal at the moment is that every time someone commits some code, anyone on the team commits some code to Hazel, pushes some new code, we want to like run that code. We want to make sure that it compiles on all like build configurations, all platforms, that kind of thing. And then we want to also like run the engine, test it, and make sure that that code hasn't broken anything. It's obviously very useful if that just happens automatically behind the scenes anytime new code is pushed. And once that kind of infrastructure is in place, it can extend a little bit more. So for example, if someone's proposing code changes in the form of like a pull request, that can actually be evaluated first to make sure it integrates nicely and all the tests pass and the code compiles and all of that stuff before a human even needs to like dedicate time and read that code and make sure that it works kind of using their own eyes. So in summary, it's all about reducing the need for human resources. And in that last video, I was discussing my thought process of how we would even integrate a system like this. And there was something called GitHub Actions, which I kind of took a brief look at, but then ultimately decided that seems too complicated. Like, I gotta set up all these like scripts and install stuff on my computer. Why don't I just write a simple Python script that just polls the repository, sees that there are new commits on a particular branch, pulls the code down, you know, runs it, that kind of stuff. And that was basically what I had settled on. In fact, Peter and I even talked about it, and we decided that this was just gonna be so much easier. Why wouldn't we just go down this route?
It just sounds like setting that up would just be more complex.
Why wouldn't we just do it this way? And then the next morning I woke up, and what tends to happen sometimes, actually probably more often than I'd like to admit, I'm lying awake in bed at night and I'm just almost subconsciously thinking about stuff. And I was thinking about Hazel, and all of these thoughts were kind of coming into my head, and I was like, but you know, it would be really nice to use GitHub Actions. And everyone in the comments like seems to be telling me that it's not that hard. Like, are they really all wrong? Like, wouldn't it be nice to integrate this better with GitHub so that, for example, anyone on the team can easily view logs and build statuses, and we would get that kind of direct communication between GitHub, the repository, and the actual like CI machine? This guy over here. It's obviously just a more robust system. Would it really be that difficult to set up? No. No, it turns out it's really easy. Turns out it's really easy. I don't know. I think sometimes it's easy to kind of be lazy and assume that, oh, whatever, that's too difficult. I'll just do it the way that I know how to do it without daring to venture in a little bit deeper and potentially learn something new. Like, I'm definitely guilty of that. So if anything, just let this video kind of be a reminder to you that you should properly evaluate certain things. Like, actually give it like some time before you decide that that's not an appropriate solution for you. So yesterday, Friday morning, I just booted up the QA PC and I was like, I'm gonna give GitHub Actions a fair go. Like, I'm gonna spend like at least the whole morning going through and trying to set this up. Because ultimately, like, I'm aware of all the benefits that it provides. It's just that I was a little bit scared of the kind of upfront cost of setting it up, I guess, but then also deploying it to more and more PCs that we would have to do. We'd have to get more devices to test Hazel, and I was a little bit worried that it might not be as configurable, as easy to spin up a new PC and get it to run all of these things and compile the code. But no, I think it's gonna completely satisfy all of our needs and goals. It is in fact very flexible and very configurable. And so the rest of this video, I'm gonna talk about how I set this up yesterday and how it's currently functioning and our plans for it in the future as well. So before we jump on this computer and I show you in depth everything, the main kind of takeaway here is that this is just a self-hosted runner, and the process is really simple. Your repository just needs some kind of workflow file, and that workflow file just defines, like, I guess, what actions need to be taken to complete that workflow. And so once you kind of have literally a series of steps of what you want it to do, as well as when to do it. So for example, when there's a push event, when someone pushes code into the repository, I would like to complete the following steps. Once you have that, you then need to get something like some form of runner or device to actually kind of listen for those events and then execute your steps for you. Now that can be either a GitHub hosted runner or it can be a self-hosted runner. We went for a self-hosted runner because it made a lot more sense. First of all, it's completely free because you're the one providing the hardware, not GitHub. So you're not paying like essentially a price per minute of that kind of hardware being allocated for you by GitHub. There are free minutes included, of course, but that's kind of besides the point because we know that we want to control the hardware, we have the hardware, and we need it to be a little bit more customizable than perhaps GitHub can offer us. Because what we're testing here is a game engine. We want it to be able to run with specific GPUs and drivers and kind of record frame rates, and the environment definitely needs to be controlled by us. So of course we went the self-hosted runner route. I did, by the way, mention this in the previous video. I added a little note there being like, yeah, we could do a self-hosted runner, but it'd probably be more trouble than it's worth. If this is the computer that needs to run that stuff, then I guess GitHub Actions goes out the window, at least as far as I'm aware. I don't know, maybe I'm missing something. That's always possible. You guys can always let me know. I was wrong. It happens. We all make mistakes. I'm just glad I was able to kind of fix this quickly and early. So anyway, for a self-hosted runner, all you need to do is, so step one. Here we have the Hazel repository. This is the one you can get on patreon.com/thecherno if you help support the project. This is the full version of Hazel. And by the way, once you do sign up on Patreon, all you have to do is go to git.hazelengine.com, connect your Patreon and GitHub accounts, and you will automatically get invited into this repository. So it's a really kind of instant process now. Back in the day, you had to message me on Patreon, wait like up to a week potentially for me to give you access. Doesn't work like that anymore. So inside this repository, if you go to settings, this is really like step one if you want to do this yourself. If you go down here to actions, you have to basically enable actions. So disable actions was kind of the default for this repository. I had to not only allow Studio Cherno actions and reusable workflows, which is what I thought you had to do because this says that any action or reusable workflow defined in a repository within Studio Cherno can be used. But then I was actually getting errors saying that, hey, you're using stuff that isn't in Studio Cherno, which didn't make sense to me because I was like, no, the workflow file, which I'll show you in a minute here, was inside a Studio Cherno repository, but it's because I was using actions that were kind of on the marketplace, as it's called. Basically, I was using an action at that time called checkout, which just clones the repository. You'd think that was like just a normal thing. But that action, I guess, technically isn't my action. I'm kind of importing it as like an external package almost. And so for that, you need to allow non-Studio Cherno actions that are either created by GitHub or allow actions by marketplace verified creators. So that needed to be done before it would actually run my kind of build action successfully. So that's worth noting. Once that is done, if you go back to your repository, you'll see that there is an Actions tab. So over here, you just click on Actions, and here we have kind of the dashboard of all workflows, and here's our build workflow. We'll get into that in a minute. But the first thing that I ended up doing was back here in Settings, under Actions, there's this section called Runners. So under Runners, you can see we can host our own runners here. I had to click New Self-Hosted Runner, and then the setup is really easy for that. So this is how we kind of download essentially an application onto our computer that turns it into this kind of self-hosted runner. It's basically just a little app that you would typically run as like a Windows service so that it's kind of persistently running, and it will basically communicate with GitHub. There's a lot of documentation. I might leave it below if you want to read about how it actually does the communication and stuff, but the gist is just that it will communicate with GitHub. In doing so, it will be able to pick up events such as push events, and then it will execute whatever workflows you define right here on this computer. So that's kind of what it is. It's a runner. It will run whatever workflow you define on this computer when certain events happen, and it does so by communicating with GitHub. So we have Mac OS, Linux, Windows. You can select whatever architecture you want as well. These commands are really all you have to execute. I made a directory called Actions Runner. Here it is, kind of on my local C drive, just at the root, because it said under drive root, so I was like, whatever, I'll make it there. And then you can see this is what downloads the actual runner. So you just like run this in PowerShell, or just like in the terminal app, which typically is PowerShell, or Windows PowerShell to be exact. You can optionally validate the hash if you like to make sure you downloaded the full file, and then this will just extract the installer. Finally, you just run config with a token that I probably shouldn't show you guys. I don't actually know if that's secret or not, but I'll blur it anyway. So yeah, just run this config, which is, you can see over here, kind of in these extracted files that you've just downloaded, and then you just run it. And that's kind of it. So that's the entire setup you would need to do if you wanted to get like a new node or a new computer being a self-hosted runner. For Linux and for macOS, similar setup, which is important because I'm definitely going to be doing this on Linux in the future. But for now, we're just setting it up on Windows. So you can see also it says here, use this YAML in your workflow file for each job. Because basically when you set up a runner, it gets a series of labels. And if we actually go back to runners, you can see that this Studio Cherno QA, which is just the name of this computer, that has these kind of labels attached to it. Self-hosted Windows x64. That's nice because you can define certain workflows that only run on certain labels, basically. So like only run this workflow on a self-hosted runner, or only run this workflow on a Windows runner. So there's all this talk of workflows. So what actually are they and how do you set them up? Because that's kind of the important thing that dictates when to perform what. So that also is rather simple. If we go to Actions, we can create a new workflow. And then you basically choose a workflow to start with. And these workflows are just kind of defined by YAML files, which is great because I love the YAML format and I think it's really simple and easy to understand and easy to read. So what did I start with? Well, we don't use make. So I kind of just wanted to see in general what C++ workflows do you have? And then I found MS Build based projects, which is perfect because we use Visual Studio to build Hazel, and MS Build is obviously the compiler that Visual Studio uses for, you know, building stuff. So I just used this as a starting point. That's basically what it is. When you hit configure here, you can see it's made a new workflow under your repository under .github workflows. Here it is. You can call it whatever you want. It's a YAML file. And this is kind of the code that it gave you. So this was my starting point, which is great because you can see that it does two kind of critical things, or three critical things even. First of all, it uses this actions checkout. Now, checkout v3 is not the latest version, v4 is, so I went ahead and updated that. Actions checkout, what this is and where it kind of exists is over here. So github.com/actions/checkout. This is the repository, checkout v4, that's the latest version as of me recording this. It tells you how to use this, which is great, so I definitely consulted this because I needed much more than just a simple checkout, and I'll show you my YAML file in a minute. I'm just kind of talking about the journey. So that's obviously very important because that checks out, you know, the repository. That does a clone of the repository so that you have the repository now on your self-hosted runner. Then the next critical thing that it does is it adds MS Build to path. And again, if you want to look at this, you just go to github.com/Microsoft/setup MS Build. Yeah, here's the repository and you can figure out how to use it. You know, NuGet packages, didn't need that, we don't have any. And then the other critical thing that it does for us is you can see that it runs MS Build in the working directory, which is basically where it checked out the code to. So this is that directory that you checked the code out to, and it will basically build whatever build configuration you specified over here and whatever solution file path you specified over here. So this was a really, really good starting point. You can also see up here that this is what it does these jobs on. So on push event for which branch? For me, I made it dev because that's our kind of branch that I wanted to test. Master is already our release branch. So the only stuff really going into that branch is stuff that's already been tested and it's effectively released. So very rarely code is actually pushed there. Dev is definitely the branch that, you know, gets commits almost every day. I want to test that. Now, the idea is you set this up however you like. I'll kind of move it over here. You can commit the changes right from here. You just press commit changes. You add whatever commit message you want. Oh, by the way, if you want to change the branch that it goes to, you can just hit this files and then this is how I changed it, you know, to be in the dev branch. And so now you can see we're in dev and we can commit the changes like directly to dev. So that's where I put it. But you basically just do that and then like, that's it. As long as your runner is running as a Windows service, well, actually you don't even have to run it. Like you could just hit run, for example, and you can see it'll connect to GitHub. It'll give me an error here in a minute saying that it's already running because it is, but you can run it from here. You don't have to run it as a service, but typically it does install it as a service. And that's good because you can see we have this GitHub Actions runner here. Now, I did have to make one change, and that was I had to basically change this logon. It was running this as like a limited access kind of network authority account. I changed it to be local system account, which gave it admin rights, and that was necessary for a couple things. First of all, because I added a step where it downloaded and installed a particular version of Python, because we use Python to run like all of our kind of setup scripts. That requires admin rights, so I had to change that. But then also Hazel's own setup scripts also creates symbolic links in order to kind of avoid copying some files. And those symbolic links require admin privileges as well. So that's what I had to do to the service, but otherwise, that's kind of it. Every time you now push, it will run this stuff. And you'll be able to see every run inside this Actions tab. So now let's quickly take a look. Before we explore the Actions tab a little bit more deeply, let's take a look at what our YAML file actually looks like. So this is it. This is the complete YAML file. I called it build, pretty self-explanatory. You can see it's being triggered on a push to the dev branch. And inside the environment, all I've specified is the solution file path. If you were paying attention, you'd notice that I removed the release configuration, but we'll see where that's gone later. Permissions I left on read, which basically just allows it to read the contents of this repository. I don't need it to write anything to the repository. And then here is the job. So you can define a series of jobs here, but we only have one job. It's called build, and this kind of defines all of it. So if we take a look at this build job runs on Windows and self-hosted. Again, what that means is if we go back to the runners, you can see this has both the self-hosted and the Windows label. So that basically means that this workflow can run on this runner. And if we had like some non-self-hosted runners in the future, for example, this wouldn't run on that because I only really want to run this on like this computer. And then we have something called a strategy, and that's because I wanted to set up a matrix. Now there's some great documentation on this stuff, which I highly recommend you take a look at. Basically, the reason why I did this was because I knew that this wasn't just as simple as I want to build debug and that's it. I wanted to build debug, release, and dist. I wanted to build all of these configurations. And so what a matrix lets you do is it lets you basically specify a series of different parameters, and it will automatically run every possible combination of these. So if I also had some other like defined specified, let's say for example, actually probably the documentation is probably more useful. So this example here where we have 2 different OSs and 3 different versions, it's gonna run that 6 times because it's gonna run these 3 versions for this, and then these 3 versions for this. So every kind of possible permutation is gonna be run. Now in this case, it's only kind of 1-dimensional, we just got these 3, but it will basically run these potentially in parallel and show the results to me as like 3 different kind of runs of this workflow. So that's really helpful because of course, I need to test all of these. So here's our actions checkout for. So this will check out, I don't know if I had to specify this. I won't lie, it took me like an hour or 2 and probably about 18 revisions to this to get it to work. Because I was doing this for the first time and I was reading the documentation, trying new things. So it's possible that this is just already in the environment variables, and if you leave it as default, then it will be fine. If you actually go to like checkout, this is the checkout repository, you know, that's where I got this from. So you can see that it's a repository name with owner, but the default is GitHub repository. So I'm assuming that I don't need this, but nevertheless it's here. Now submodules, I did have to set to true, and LFS I had to set to true because these both default to false, as you can see. Then I set up a specific version of Python 3.12. This is what required those admin privileges. For some reason, for the life of me, I couldn't get it to find existing Python installations. I figured this probably isn't too bad because this will install it if it's not there, I assume. It probably gets cached somewhere in the runner so that it doesn't have to keep installing in every run. But I think this is a great little thing to have because it ensures that you have a valid working version of Python, and it's the right version as well that you know is compatible. MS build, it will then find this default architecture was x86, so I changed it to x64. This doesn't install MS build, it just finds the existing installation without much trouble. Then we have a setup step over here. So what this does is from the scripts directory, if we actually take a look at the root kind of Hazel repository, we have a scripts directory, and then we have this kind of setup.bat, which just calls python setup.py. So this is the kind of setup script that will make sure that, you know, we have the right version of Vulkan installed. It'll run premake to generate the Visual Studio project and solution files. It'll pull like submodules. It'll just make sure that everything's kind of set up for you. So that's me calling it here with, you know, inside this working directory, which is going to be the checked out root of the repository. But then we're changing into the scripts directory because it has to be run from there. If you use this pipe here, you can specify as many lines as you want of different commands. So that's what I'm doing here. And then so after this step, we now have the Visual Studio project files and the solution file generated. So we can now call MS build. So this step is just called build. Again, inside this working directory, it will call ms-build with the solution file path, which is specified over here, hazel.sln, that's our solution. /m just means that it will build the projects in parallel. And then we have an actual property here, which is our configuration set to, you can see matrix.build configuration. So that is this. So whatever kind of variation of this matrix that is being run at the moment, whether that be debug, release, or dist, that is the kind of variable that goes in here. And then we're also outputting a log file. This isn't strictly necessary because we'll be able to see all of the logs over here in GitHub, but it doesn't hurt to just have a text file with your log on the actual computer. So that's what this is, and that's it. That's our entire workflow at the moment. And so the way this works is when someone pushes to the dev branch, it will automatically start like one of these workflow runs. So you can see, for example, this was me yesterday, trying to work this out. This was the first build. I deleted the ones between 1 and 18. That's how many attempts it took me to actually get this running. And then you can see it's gonna run all of this, and that's how long it took. So every time dev is pushed to, it will basically communicate with the self-hosted runner, in this case that we've installed on this computer. And what it does is a completely kind of clean, from scratch execution of this workflow. So over here inside this actions run directory, there's this _work folder, which it asks you what you want to call it. That's the default name. And then inside here, you can see we have Hazel, and then this is the checkout of the repository. Now it nukes this, it deletes this every single time that it runs. Oh, there was one thing that I forgot to mention, and that's this fail fast false strategy. So this is important because since there are multiple kind of build configurations here, it won't run them in order because, as I mentioned, they can be parallel. I didn't actually see it being run in parallel here. Maybe I have to do something else for that. But either way, it randomly selects one of these to run first, and if it fails, it stops all the other actions. So it doesn't proceed to test the other configurations. I didn't want that happening because sometimes like a debug build will fail, but release and dist will work, or dist will fail and debug and release will work. So I want to know if all of them are broken or if just one of them is broken, or something like that. So fail fast means that it's not going to abort everything if one of them fails. So that was important as well, because before I updated it, it was failing fast. Now immediately once I kind of enabled this yesterday, a real world use case actually just naturally happened, which is great. Like, this was useful immediately because you can see that I finally fixed Renderer 2D. I did a live stream about this. It'll be on my Cherno Unplugged channel, by the way, the VOD for this. But I was working on like extending Renderer 2D in Hazel so it can dynamically resize how much it's able to render. And you can see here that the debug configuration failed. That's the one that it happened to run first. And so you can see it didn't do the other ones. But if we look over here, we can look at the logs. We can see that it failed. Why did it fail? Because, check this out, we have a compile error. It's saying quad vertex buffer base undeclared identifier. So that actually prompted me to take a look at that because I made the rookie mistake of not compiling my code in all configurations. I didn't compile it in debug. I was just using the release configuration and I assumed it would work. And then that led me to push this, which did actually succeed, and that was me removing an assert. Because this assert only gets compiled for debug builds, it gets stripped out of release or distribution builds, and this was using a variable that no longer existed, and in fact this whole thing is kind of obsolete now because it uses a different system anyway. But the fact that it was in an assert meant that the code was stripped in the release build, so of course it wasn't a compile error, but it was in debug. So well done CI for catching that, because I was obviously too lazy to build in all configurations. And you can see that, all 3 jobs were completed successfully: debug, dist, and release. You can click on them. You can look at all the actions. So for example, here's us, installing Python. Here's us finding like MS build. Here's us running the kind of Python setup scripts to generate all of the project files. And you can see there actually is an error that I still have to fix for that as well, but it's not overly critical. And then here's the actual build. So this is the big juicy one, that this is the entire log from it actually, compiling every single like CPP file and building the actual projects with 41 warnings, 0 errors. And that's kind of it. So anyone on the team can obviously access these logs. They can see what's going on. If they've pushed something, they can see what the error is. This is going to become a whole new level of useful when we expand this to also run on Linux. Because a lot of the times you might not have like a Linux PC available for testing. So you push something, you think it's fine, but then turns out it builds on Windows and not on Linux. And the fact that it can obviously get automatically tested is amazing. Not to mention, when we take this a step further And we don't just build it, but we run it and we test it and we run all the different automated tests that we have. Because that's kind of going to be step 2. We'll improve it with each release so that we can also focus on developing features for Hazel and getting all that running. So this is kind of like Mark 1 of this system. And yeah, it's amazing. Hopefully this video was helpful if you wanted to set up a system like this for yourselves. I hope this was fairly thorough. As I mentioned, like the only real 2 issues that I had was initially just making sure that I changed the kind of permissions from this to this so that I could run these external actions as well. And then also making sure that the actual runner application running as a Windows service had the appropriate administrator privileges to do administrator things. Hope you guys enjoyed the journey. If you did, please don't forget to hit the like button below. You can also get access to Hazel and help support its development by going to patreon.com/thecherno. And I will see you guys next time. Goodbye.